Okay, lovely. So yeah, my name's Matt DeMarco, if you haven't met me before. I'm part of working group or subgroup 2, and we're trying to or want to show people how to deviate from specifications, material specifications. And the idea, or the original idea, it still is to come up with a dedicated pathway for government clients and private clients to commit to speed up this process. So if we have a better way to do things, if we have a more efficient way to do things, we don't want to be waiting 6 months, a year, 2 years to deviate from a spec or to get approval to deviate from a spec. It's a lot about dealing with personalities and people who own this spec, and they're required to, all the risk is upon them almost. So it's dealing with those types of people, and we're trying to coach people along on how to do that. So it's a long process. We didn't think we were going to get there, or within the past 6 months. It's going to take a while. But for this presentation, what we want to show people is how we've done this in the past. And is there a magic formula that people on projects or anywhere around the country that can use as advice? So if they do have a better way to do things, here's a bit of a process that they can go through. So we're going to look at government and also the private sector. Government sector going to look at the big ticket items, so pavements, and the private sector, which have got some good examples from Goodman. If you want to deviate from their specs, this is how to do it. Government deviation from specs is a lot more difficult, it looks like, than from private sectors. And if anyone is in that private sector, I'd love to get your feedback if you're separate from Goodman. But we'll go through some examples that we've done in the past, from asphalt to concrete shared user paths at the beginning, and then I'll show you what the commonalities are. How did we deviate, and if you could do it again, what's the pathway to success? So, first of all, those pictures up the top there, that's an example of deviating from a specification. And that's our concrete example, and I'll go through that in a bit. But the first one is asphalt, and everyone knows about Reconophalt, and in particular, what's different about Reconophalt is Tonoplast. So Steve Morris down in Victoria, and this product's been around for a very long time. It's been tried, tested, and proven, but still it's very hard to get through or get past specifications. So we tried this on the Central Coast. This is through John Holland, and we got there. And it took 3 months to deviate from the specification. The client was Transport for New South Wales, and the method was to lower the risk profile for the particular decision makers in that process. And this is how we did it. We identified who are the key people, who's going to be signing this off, who's going to be affected by this. And it was our design team, our project team. It was the asset owner, which was the council. It was the maintainer, which was the council, and also TFNSW. Liability stood with John Holland, but also TFNSW. The manufacturer, which was Downer. So we involved all those people right at the beginning, and we told them what our intention was and what we want to do. Right from the beginning, we wanted to gain interest. We wanted a green light. We wanted to go, okay, cool. If you get us all this information, it'll get approved. And that's the key question that we found that works with every single deviation that we do. What do you need to sign this off? And the person right at the end with that pen, they will tell you what they need in writing to see in front of them for them to sign this off. And then we go out and get it. From there, every single project has a different departure process. It's in the contract. You just have to understand that so you know the formal pathway forward, because you'll need that at the end. We did the usual things to start creating our business case: cost, performance, maintenance, and also who holds liability, which can get very, very ugly at the end. We wanted to make sure we ticked all those boxes. So we got the cost sorted with Downer, we got the warranty sorted with Downer, the usual warranty. We proved performance. We've got all the data you can think of. And if you do know Reconophalt, there is so much data out there. It is ridiculous. Back then, you needed EPA approval. that's all sorted now. So we made sure that the EPA was okay with Tonoplast in particular. We got liability signed off by John Holland in our usual 2-year warranty, and that gets a bit more convoluted when we go to the next example, but I'll go through that later. And then we started to develop that business case. But going back to the very first question, what do you need to sign this off? And in that business case, it addressed every single question that each stakeholder had to lower the risk in their mind that this is going to work and there's nothing wrong with this, but also actually it performs better. And it worked. We got all the questions answered, put that forward, and eventually we got the verbal green light to go, okay, cool. Yes, this can happen. Put through the formal design approval process, put it through that process, and it'll be signed off. So we went through that design approval process knowing from the beginning that it was going to get signed off. One kicker here for every deviation is the asset owner. Whatever the asset owner wants, they'll usually get. And that was a big part of that stakeholder piece right at the beginning. So Central Coast Council, Boris at Central Coast Council, he was the owner of the spec. He signed everything off. And if the council wants that product, he wants that story in their vicinity, they're going to get it. So he wrote us a letter saying, hey, we want this to happen. And that was a big, big help for us to get this over the line. So we got the approval to use and away we went. So there's a 100-meter, 200-meter stretch of road on the Central Coast that is a Reconifol and Tonoplast mix. We went to visit recently after about almost 2.5 years of it being laid, and it looks like it was brand new. It's performing really well, especially in that area because it is a huge flood-prone area where pavements get ripped up all the time, and it's performing really, really well. So that's an example of deviating from an asphalt spec, in particular R116 from TFNSW. All right, the big one here, which I'd like to talk about, is concrete.
Hey, Matt, how long did that last one take you?
3 months to deviate. 3 months to get over the line. And that's making sure everyone was on board from the beginning. So that was quite quick, 3 months. The next one I'm going to show you took 1.5 years. And we're still going through this process. Any questions about the asphalt example before I move on? Cool. All right. This one here, the biggest pain in the ass at the beginning, but it has turned out to be one of the most incredible things I think we've ever done. Geopolymer. Geopolymer is very contentious out there in the concrete manufacturing world, depending on who you talk to, whether it's Holcim, Boral, Hanson. It's concrete with no cement, and cement is very cheap to manufacture. That's how the money's made there, along with the aggregates. I'm sure there's some concrete manufacturers on the line right now, and it's made using an alkali activator. Alkali activator is probably the highest carbon producing material in the mix design, but our aim was to create a geopolymer concrete with recycled glass, replacing some of that aggregate. The glass and geopolymer hasn't been done before in the world, but geopolymer has been done previously, especially in Queensland and way back in the day in Melbourne, and it's still used in precast these days by people like Humes, etc. And we wanted to pour a geopolymer mix and make it commercial in New South Wales. We started this journey and we brought it to TFNSW, and they looked at us and go, "No, you're a bunch of idiots. Get the hell out of my office." We kept persisting with this, and we had all the literature, all the data, and all the forecasts from low carbon impact to cost to why this was beneficial and how this could also open up the doors to all the current concrete manufacturers out there who already have these off-the-shelf product. Look at Boral, look at Invisia, look at Holcim's triple blends. These are all low carbon alternatives. And we thought if we could go right to the top and go, hey, what's the most out there? What's something that's the lowest of the low carbon footprint concrete? If we can get that approved, and then that opens the door for Hanson, Boral, Holcim to go out there and then freely use their low carbon products on projects with no questions asked. So we went through, it was a lot of persistence. It was once again lowering the risk profile, because the people signing this off, we're not the subject matter experts when it comes to pavements. We involved external SMEs to convince them. It like I said down here, it took 1 year, 2 months to get the green light to proceed. And that example you saw at the top of those slides was geopolymer concrete at WestConnex Roselle Interchange in Sydney, and we're doing our second pour next week. And from this is all non-structural concrete. From this, TFNSW loved it. They see the value, and we are doing a structural concrete demonstration on a Sydney Road project, and that'll happen between September and February. So how did we do this? Once again, we identified all the stakeholders. Who is affected by this, from manufacturers, the specification owners, who's signing this off, who's building it. You've got John Holland, CPB, you've got Boral, who's the concrete manufacturer. You've got Redox, who we're getting the activator off. We've got life cycle assessment people doing the work for us. It was a whole bunch of people. Who's going to be maintaining the asset? Everyone. Eventually, through all those conversations, we lowered the risk. We made everyone see the benefit, and we asked the question, what do you need to see to sign this off? And that list was huge. We answered every single question, and we used subject matter experts to come in to back us up to lower that risk profile, to answer those questions for us. It was pretty much a roadshow, and we finally got the green light to sign this off. And how we did this was we developed a research development program, and we gained funding from the EPA to do this, to do the research with UNSW to lay this product. We went throughout this process. A lot of this process happened simultaneously, so it wasn't like, you know, 1, then 2, then 3. It's all going on at the same time, so it's quite difficult. A lot going on. But the usual contractual departure process was in play, so we know what to do. We know how to submit the documentation right at the end. And the intention here was to create a project-specific specification for concrete at Roselle, which is going to inform a new specification or an update to the specification of R53 in New South Wales. And we're hoping that this new spec will then inform other spec updates in Queensland and Victoria and around the country. And it already has informed kind of an attention to updating the B80 spec in TFNSW. You talk about B80 and structural concrete 2 years ago, and you want to change that? Hell no, don't even come near it. But now TFNSW have seen the product work on site. It went smooth, it performs, and they're like, why can't we do this structurally now? Which is what we want them to start asking. So we developed the same business case and answered what you need to sign this off. It's huge. Performance data, commercially viable in the future, carbon footprint. What do you need? It's in there, and it convinced everyone. And we got the liability signed off, and TFNSW ended up taking the liability of this product, of this pavement. They're going to be monitoring it. And a big part of this was there's zero IP. Everything we do, we voice to the world, so everyone can do the exact same thing. We got the liability signed off. We got the agreement signed off with all our partners in the project, and we went through that departure process, knowing in the background that yes, we are going to get the green light, and we got the approval to use it. There's 3 stages to this. There's geopolymer, then there's geopolymer with glass, which is happening in the next couple of weeks, and then we're going to optimize that mix. Right now, we have the lowest carbon footprint known in the country for a concrete mix, a lot lower than Envisia. The first trial, the only thing that beat us was Wholesome's triple blend, but then we optimized that mix even further, and then we got below Wholesome's mix in terms of how much carbon our mix design produces. So it's very exciting, very cool. And the biggest thing about this was dealing with personalities. And I was just talking to Tony Alosio the last couple of hours this morning, because they're doing some amazing things in Victoria, and we're going to be helping them hopefully in the future do some amazing things with this type of deviation. It's dealing with personalities, and they don't have we don't blame them. You know, they don't have the specific skill set to be looking at this and go, okay, if I sign this off, am I confident? Like, I'm going to take all liability. So it's kind of to get to know that person and what makes them tick. And bringing that person all the way along the journey to educate them and lower the risk profile. So the people at TFNSW, over the past 2 years, they've learned a lot with us. They know that this works now, and they're also supporting us out there in industry. The people who said no are now talking at concrete institutes, at forums, talking about this project, about what they're doing and how they want to do more of it. We're converting people in this process. So that's probably the biggest deviation that we've seen, and it's going to hopefully knock down a few doors and pave the way for other deviations. And to go off that, this is what we think the formula looks like. It varies a lot depending on the case, depending on the people, depending on the project, and also depending on the product. But we think that if you follow this rough guide, this is how you can deviate from specifications. It's getting the right people on board, it's getting the right stakeholders on board, and informing them early and asking them, what do you need to sign this off? And going through that process to get it signed off. And if we can formalize this in government projects, government processes, we think we can do some amazing things. So before I get to the private sector, I don't want to take up too much of your time. Is there any questions on this? I'll send this out, by the way, to everyone, and you can pass it on. We're all good? Makes sense? I can't see anyone on the screen, but I'm assuming that's a yes.
Matt, it's Monica here. So
Hi.
that issue of liability and risk, that seems to be the one, where the head engineer has to sign off on that, or the head contractor has to sign off on that. So, I mean, you've taken us through those steps to try and give them that confidence. Is there anything else that you needed to do or think about to actually give those personalities that are maybe very risk averse the opportunity to really feel confident about those materials?
It's showing them the data and taking them to the lab and watching this get tested live. Connecting them with the SMEs was a key part of that conversation to make sure that they were comfortable with this. We took the spec owners to the lab, we took them to the site, we took them to other parts of where this has worked before. It's physically showing them that, hey, it has been done, it can be done, and it works. Legal liability in terms of it was a big thing in terms of, hey, if this does fail in 10 years, who's liable, who's going to pay for it, but also who's going to maintain it? There's a cost to this. Who's going to monitor this? That was a big conversation as well. Who's going to pay for that? So getting that aligned or getting that sorted early would also help a lot to get this over the line in the end.
And with geopolymer, because it's not in the standard, you would have hit the speed bump of who approves it. How did you resolve that? Did you have an engineer who was prepared to approve it, or what did you do there, Matt?
So we dealt with the pavements team at TFNSW, so Sam Henwood's team. That team's kind of dispersed at the moment. So it was Sam Henwood, Basil Ben, and Hussein were the main engineers and sign-offs at TFNSW. How we got across to them was using ex-TFNSW subject matter experts who are now in consultancies to come back and talk to them. Go, hey, this does work, and this is why. We utilized people that they trusted in the past to get advice from, but they also get advice from these people, at the moment, right now. So we got to know them personally, we got to know who they trust, and then we use those people to get our message across.
It is a stakeholder engagement masterpiece.
Yeah.
Yeah.
I love it.
Now, I'm mindful Sky was keen to try and give us a little update, and she has to run to something else. Did you say you've got more in this deck, Matt?
Just on how the landlord and private sector does it. I can send this out to you and you can read it yourselves in your own time. It's a very simple process. It's an amazing process. It's the power of private industry, and you can do what you want to do almost. almost. So yeah, that was a quick couple of slides. So I'm happy to jump off and send this around. And you can also,
or we do round 2 at the next meeting, just so that we can hear from Sky. Let's come back to chapter 2 at the next one.